Hi, good morning, everyone. So, this session is about the BGP best practices and policy design. So, I will just start the session. First, I will display a few of the introductory slide about the APNIC, and then we will formally start the presentation session. So, my name is Imtiaz Sajid, and I'm working with the APNIC as a network trainer. And those of you who maybe do not know about APNIC, APNIC is a regional internet registry which is operating in Asia Pacific region. And our primary responsibility is to register the IP addresses and then regulate them. So apart from the registry, we have the APNIC Academy platform as well for the community, for our members, and even for non-members as well. So this actually platform, through this platform, we provide the training within our region. And if you go to the APNIC Academy, you can do online courses there. We sometimes conduct the live webinars as well. We have virtual labs there, and we also provide technical assistance to our members. That's free of the cost. In case they have any issue in their network, they can raise a ticket with us, and then we will have a Zoom session with the member and we will help him. This is more or less what I have just described. So the virtual labs there, they are free of the cost. So anyone who can have an account there, just you need to have an email. You can register your account, and then you can do the lab regarding like BGP, OSPF, DNS, Linux. So these labs are available 24/7, and there is no limit like how many times you want to do, you can do it. You can even save your lab. If you have done like half of the lab, you can save, and then you can resume it after like within 7 days. But if you come after 7 days, then it's actually reset to start. You can also check there the upcoming events. We actually conduct online trainings and face-to-face training within the Asia Pacific region. In case of online training, you can join from your home, and in case of face-to-face, you have to register depending on where it is happening. We also like APNIC is a policy-driven company, sorry, community-driven company. So we ask community to propose policies, and then based on those policies, actually, if community members agrees, then those are getting implemented. So you can get in touch with us using this URL as well. There is a sister concern for APNIC Foundation. So this is actually the organization which actually provide different option for the community to where they can propose some projects, and we actually provide funding to help them to complete those projects. So this year the application they are closing on the 4th of the April. So in case you have any project where you think like you need some funding, so you can apply and then it will be reviewed by the committee, and they will let you know what is the outcome of it. Okay, so that's the introductory slide. So now I will formally start our BGP session slides. So just to start with the introduction, those of you who are not maybe familiar with BGP. So how many of you are already working in a role as a network engineer or system engineer? Can you please raise your hand? As a network engineer too? Have you heard about BGP before this? Okay, still it's fine. So just to have everyone on the same page. So first I will just give a brief introduction about the BGP. So it would be just a refresher for you if in case you already know. So what is like the internet? So in case of internet, it's a collection of the networks. Like one network connect with each other, and then they share the routing information with the other networks, and both of the network they receive the routing information. Like they exchange the routing information, they will advertise their information and accept the information from the other network. And this is how the internet has been built. So we have AS like 100, which is connected with AS2, and AS2 is connected with AS300, and AS300 is connected with AS100. So it could be like, this is just an example. There could be cases where they have like maybe just one connection with other network or multiple connection with other networks. So what is an AS number? So if we want to define an AS number, so actually a AS number is a network under a single administrative control, and it has a unique or uniform policy across its network. So a network which is under a single administrative domain, and it has a unique policy for all of its devices, you can say, like similar policy. So in-out policy would be same. So here we have an example of AS100. So these are the collection of router which are under this AS100 administrative domain, and they have same policy when they will be exchanging the routing information with other networks. We have also, when we say the BGP, so we need to establish a session between two networks. So there are two kinds of BGP session. When we establish, we want to exchange the routing information between two different networks or within same network. So when the BGP session is established within same network, that's mean the participating router, they are having the same AS number. So here the both of the router, they have the AS100. So that means they belong to the same AS. So this is called IBGP session, internal BGP session. There is another kind of BGP session which is established between two different ASNs. So this is actually established between the router which are from the different AS number. Like here we have AS200 and AS100. So in this case we call it eBGP session. So what are so BGP itself, it's an exterior gateway protocol, like it's used to exchange information between two different networks or between two different AS number, and it is designed to exchange the routing information between different AS number, as I said. So here we have the example like AS65001 and AX6500. So these two ASN, they are using the BGP to exchange the routing information. Just to let you know, these slides I will share through the Academy portal. So the slides are available there. So in case you do not need to worry about recording them. So they are available in PDF format. I will share the link at the end of the session. If you need to download now, let me know, I can help you. So there are two kinds of mainly protocol. One is we call the link state protocol, another is path vector protocol. So BGP is a path vector protocol. It actually uses the AS path attribute. That's the main feature of the BGP. That means when it exchanges the routing information, the path information is retained along with the routing information. So when you receive a IP address prefix from another network into your network, so it actually has the information like from where it was first originated, then what are the different AS it has passed through, and finally from which AS or which network you have received. So it's just like give you an example. If we look at the flight ticket of somebody who came into Japan, like from wherever, which part of the world he is coming, like maybe from Asia or from Australia. So if we look at his ticket, we can see like he has a direct flight from his country to Japan, or he went through different transit. So like maybe I came from Australia, so I like took the flight from there, reached to Singapore. From there, I had like from there another flight, and then reached to Japan. So somebody, he will look at my ticket, so he will be able to know like from where I had originated and what was the transit in between. So similarly, in case of BGP, this AS path attribute actually gives you the information how you have received this route. Other protocols, they unfortunately do not have this information. That's why we use this protocol to exchange the routing information over the internet. So it propagates the updates dynamically. That means you do not need to send or push the updates. You will automatically pass on the updates to other network, and you receive from the other networks as well. Another feature is like it prevents the loop within the routing. That's mean when you advertise some routes, and if somebody else send you back the routes, so you check, okay, my own AS number or my own network number is present in the path or not. If it's present, I will just discard it. It's similar like you are giving some information to other colleagues or your friends, and if same information is given to you to back, you will say, okay, I already know this, don't need to tell me about this information. And it actually, another feature is like when we are exchanging information between different entities, different networks, we need to have some sort of control. Like when we travel from one country to another country, there is a immigration office or border control which actually try to filter or try to police who is going out or who is coming in. Similarly, in case of BGP, because we are exchanging the information with other networks, so we need to have some sort of policy control. Otherwise, whatever the information will be sent from other networks, either right or wrong, we will be forced to accept it. That's why we want to have a policy. So we cannot trust others, although BGP or internet is based on the trust, like we trust each other whatever information is shared, but still we want to have some sort of policy so we can have a control. So it gives us a way to apply policy in inward direction and outward direction as well. So in case of BGP, we just exchange the routing information. We do not exchange the network topology. Like when I advertise my prefixes, they don't know how many routers I have within my network or how they are connected with each other. So that information is still hidden. It is not exposed. So another feature for this, the BGP is the only routing protocol which can handle the internet routes over the internet or the global routing table, because the size of the global routing table is very huge. Like nowadays, maybe you will see 1 million, almost 1 million IPv4 routes. And in case of IPv6, it's above 250K or approximately around it. So this is an example, like we have a prefix 1.1.1.0/24, and this is the AS path information. So you can see the first AS, it is 300, who has first originated this information, then it passed on to 200, and it if I am AS like maybe 10 or 20 or 1, so I have received from AS 100. So this last is AS 100 is showing me from where I have received. So it's just looking at the flight ticket. You can check what is the previous hop from where you have reached. So how the path vector is implemented. So AS65, like here we have three AS, sorry, AS6500, AS65001, AS64512. And here you can see I have a network 172.18.1.0/24. So this network is available within this AS6500 network. So what it does, it uses the BGP to advertise this AS information to other networks. So it will advertise this information to 6500. When it will advertise, it will attach its own network number information along with the prefix. So when 65001, it receives this AS. So this AS path attribute will have the AS number available within it. So when 65001 it will receive, it will then advertise to its neighbors or its connected networks. So who is connected with the AS 65001, 64512, and even 65001. So this 65001, it will actually advertise back to it as well and advertise to 64512. So when it advertises to 64512, it will add or append its own AS number. So now you can see here let me highlight this. So here the AS path attribute is only having one AS information. But when this AS number, AS65001, it advertised towards 64512. It adds its own AS number in the path. So it at the end it will add, and then it will reach to 64512. So now 64512, when it receives it has the origin, which is the first AS, and the transit AS, which is the second AS number here. So it will receive this information, install it, and then it will advertise to its neighbor as well. So it actually advertised back as well and in this direction. But this AS65001, it sees its own AS number in the path, so it just discard that advertisement or information. And similarly, when 65001, it sees its own AS number in the path, so it is same like its own AS number, so it will just discard this route advertisement. So it will just reject it and not use it because it sees its own AS number in the path. So that's the loop avoidance mechanism, how the BGP avoid the loop mechanism within the routing advertisements. So let's see how the routing happen over the internet. So this is handled by the eBGP, and we do this by exchanging the information between different AS number or different networks using their AS number. But within the network, we use IGP to exchange the routing information. So what I mean is, like within these two router, this is the iBGP session. But with other networks here we have the eBGP. So I and E is the word used for interior and exterior BGP protocol. But within a network, we also need a full mesh. Like every router, they will have a BGP session with each other. So in this case, you can see if we have this, say R1, and this is like R2, and this is R3. So R3 will have BGP session with R2, R2 will have with R1. Because whatever information R1 will receive, it will send towards both of them. And then they do not need to send to each other because the one who has received, it's already sending it. But when you receive the routing information from another AS number, then you actually propagate to other networks as well. So how the BGP is run within an enterprise network? So in case of an enterprise network, the BGP is actually used as a routing protocol to connect with an ISP to get the transit service from the ISP as well. So there are different ways we can say this service is provisioned or how it is configured. So one way is we call a single homing. So in that case, you just connect with a single ISP. So enterprise network, it will be connected with one ISP in that case. So just assume we do not have this connection here, and we only have the connectivity from this network towards this ISP. So there is only one connection. So in that case, we can say it is a single homing. But when we say the same enterprise, it's connected with one ISP through two links. So we have these two links. So then it is called dual homing. So like we have connected with same ISP. This ISP is not in the picture, but we have two connections. So this is called dual homing. But this does not require a public AS number. Like you can have even private AS number to have connectivity with your ISP. But when you want to have multi-homing, that means you are going to use your own IP prefixes and you want to advertise towards two different ISPs. So in that case, you have your own, this is your network, and you have your own IP prefixes like public IP prefixes, and you want to advertise towards both of the ISPs, ISP1 and ISP2 as well. So then we say this is called multi-homing. Why we use multi-homing? Because we want to have more control and more redundancy. So in case the ISP1 have any failure or there is any outage, so we can receive all the services or transit services to ISP2 as well. So we advertise our prefixes towards ISP1 as well, and ISP2 as well. We will see later on how we actually manage it, or how we try to load balance it for redundancy and load balancing as well, to divide the traffic. So in this case, you can divide traffic by having some prefixes here and some prefixes here. So in that case, you are able to manage your bandwidth from each of the ISP. Depending on your like service provisioning or subscription, you actually try to advertise more and less prefixes, and depending on the connectivity, because sometime ISP1 maybe have a better connectivity towards a certain country, certain network, then you use that ISP to reach that network. So when we establish the again the BGP between different networks, that's called eBGP, and when the ISP is advertising your prefixes towards the internet, then it's providing you the transit service, because you are going through the ISP to another network. Similarly, when you are passing through, in case of flight from one country another country, and in the middle there is you have a connection, then we say this is your transit. So same term is used in case of BGP. So in this case, the ISP actually provide the transit services to this network. So in case of transit services, we can have three different type of routing advertisement from the ISP. So this AS64512, either it can receive just when it is receiving the routing information from ISP, which is coming from the internet. So it can just receive a default route. So in that case, you actually receive just a default route 0.00.0/0. That's mean this is a just default route. If this ISP want to reach to any network in the world, if you have received the default route, it will just send the traffic towards the ISP1, and it has received from ISP2. So maybe it send one packet here, another packet here, or you can prefer one as the primary, another as a secondary. So in that case, you do not receive the full routing table. You just have one route, which is your default route. So that actually you require when you have a just single connection. But if you have multiple connection, like connectivity with both ISP, then most probably the enterprise, they prefer to have the full route or partial route from the ISP. So in case of partial route, actually you only receive few of the prefixes. But in case of full route, we say you receive the full routing table. Full global routing table copy is received from the ISP1. So in that case, you are going to receive about 1 million routes. So then your router, your gateway router, it should be capable enough to receive this information and store the information, because then you need the memory and the CPU to process that information. If your routing device does not have enough memory, then it cannot handle the full routing table. So whenever you are going to configure, you have to, before reaching this conclusion, you need to access your hardware resources or your devices, like what is their capability and they can handle this full routing table or not. Because otherwise, the memory can go very low, and then router, in order to save itself, it starts shutting some of the processes and just try to keep the critical one, and then your services could be affected. So let's now go towards the BGP policy design and best practices. What are the different best practices we should take care when we are actually designing the our policy, and there are different best practices. If we follow those best practices, then we can have a better network and maybe less issues. Meanwhile, if you have any question, you can ask me. If up till now you have any question. Okay, so next we just discussed earlier the multi-homing. So we will discuss now in more detail how like multi-homing help us to use different transit or different peerings and over the IXP as well. So in this case, we can see, just take an example of customer A. So this is a customer A, and it is connected with AS AS17821. So now this AS17821, it's providing transit services. So this customer, if it is, but this AS itself, it's advertising its prefixes to these two ISPs, ISP-B and ISP-A as well. So from the AS17821, these ISPs, they are the transit provider. But for this customer perspective, like customer A, this AS is transit provided. So it depends who is using to whom. If you see from the customer perspective, the network who is advertising its prefixes to another network, it is transit. But if we see from the AS17821, because it's advertising its prefixes to ISP, so ISP is acting as a transit. So it depends from where you are looking, where you are standing, and how you are looking. The next network could be a transit for you, but if you move to the next network and see from its ownership point of view, maybe you are acting as a transit for somebody else. There are other kind of peering we have, which is like the bilateral peering. So this is done with other networks where actually you are not paying anything. So remember, in case of transit, you have maybe have an agreement where you need to pay on monthly or yearly basis a fees for the transit services. But if you can have a bilateral peering with another network, in that case, you are just establish a BGP session and exchange the routing information where you have decided, okay, we will not pay to each other, but we will just exchange the traffic with each other using this network. But in this case, whatever the routing information, this AS17821, it will advertise to this network. It will not further advertise towards any other network. So this will not be part of this service, because if it advertises to any other network, then it becomes a transit service. So remember, in case of bilateral peering, you do not provide any transit services. You just keep the information with yourself. Because if you are giving me some information, okay, this is a parcel for you and I can keep it, but if I give to somebody else, then I'm acting as a courier for you. So similar in case of network, you actually, when you establish a peering, bilateral peering, you do not provide transit service, you keep that information with yourself. If you advertise to other, then you become like a free transit provider. So another kind of peering that is done, that could be bilateral or multilateral, that is done over the internet exchange point. So internet exchange point is actually a common point where multiple networks connect with each other to exchange the routing information. So this actually helps them to keep the traffic local. Like if the networks in Japan, they are going to connect with each other. So then when they exchange the routing information, as a result, the traffic is exchanged between them. So now the traffic will remain within the city or within the country. But if they do not have peering with each other through the internet exchange points, then the traffic will go to another country and then come back. So IXP actually help us to achieve this. So as we have different kind of peerings, so that's mean this network AS17821, it's doing the multi-homing. It's advertising the routing information with different networks using the BGP, and this is actually helping him to reach to different networks. So why we do the multi-homing? We want to avoid the failure when a circuit goes down, so our business does not have to face any hit, and we have multiple ways to do the same thing, so we have redundancy within our network. The other aspect is like multi-homing, it helps us to improve the performance. So maybe if we look at the previous slide, so here we have ISP1 and ISP2, and both are providing the connectivity towards the internet. But maybe this ISP has a better connection towards the internet in terms of latency. Because just to give you an example, okay, I'm using internet in Japan. Now I need to reach to a network in Mongolia. So maybe one ISP is taking my traffic to Singapore, and then from there it's sending towards Mongolia, but another ISP has maybe have a direct connection to Mongolia, or it's just taking my my traffic to China and from there going to Mongolia. So one which is having the shorter path, it will have the better latency, and better latency actually help you to get better throughput as well. Because when we download any file, if the path or latency is long, then your throughput is also, it become less. Even you have like 10G or 1G connection, but if 1G connection is having just like 10 millisecond latency, but a 10G connection has like maybe 500 millisecond latency, the throughput will be at the end maybe same, because there you need to send the packet, receive acknowledgement in case of TCP, and then send another packet. So another thing is like the regional based strength. As I said earlier, maybe one ISP have a certain strong connectivity towards a certain region like Asia or Europe, wherever you want to use it. Second thing is could be the satellite. One is providing connectivity towards satellite, another is having the fiber. Or so in case of satellite and fiber, the latency also can come in, and again the bandwidth. The last thing could be the like the money you are paying towards the ISP. So you have dual connection. So maybe you want to keep your primary or very critical services where you are paying more and you have better latency, and where you have the services where like consumer services where people are just browsing the internet, and you can afford to have that on a network which have less quality or long latency. So you can just divide the traffic based on that. But where you need a more quality, like maybe you have a voice calls going over a certain network, you want to have them on a better connection. So these are the different things. Like when you are having the multiple connection from your network, you consider them before you make your BGP policy, like where I need to send the traffic and how much prefixes I need to send. Because when you send the traffic, as a result, you receive the when you advertise the prefixes, as a result, you receive the traffic from the other side. Because when we order something to a restaurant, we give the address, as a result, we get the food. Similarly, in case of networks, you advertise your prefixes and then you get back the traffic from other networks. If you don't advertise your information, you will not get anything. You will be able to just to reach to them, and then they don't know how to send back to you or how to reach back to you. Yes. Okay. So the good could be these are like maybe both terms could be interchangeable or used. Like maybe something could be good and fast at the same time, and something is just good but is not fast. Maybe in terms of reliability, like one is more reliable and one is maybe less reliable, and it in terms of fast we can say like one having the longer path and one having the short path. So in terms of yeah, maybe you have a bigger maybe you have a bigger pipe, like you have maybe 100G connection, but that 100G is coming from Singapore, and maybe you have a 10G connection which is just coming from within Japan. So you want to use the one which has the lowest latency. So maybe it's you have less bandwidth subscription, but in terms of quality or latency, it is better.
Excuse me.
Yes.
Based on the BGP, basically path selection based on AS numbering in your path.
Yes, yes.
During the process, it's very difficult to get this kind of latency end-to-end delay information. So what is the best way, for the system to automatically select so-called a good path?
Okay, so very good question. So actually these things, this could be automated, but most of the things you actually are decided by the network administrator itself. When you are buying a connection, you actually sometime, maybe you have done this, you ask your service provider, give me your latency metrics for the rest of the world. And it gives you a chart where it has the cities or the countries on one side, and then it gives you the latency. Okay, from Japan to US, my latency is 200. From Japan to like Singapore, it's maybe 50. From Japan to Australia, it is 100 or whatever the number is. So it gives you a matrix, and then you actually already know, okay, these are the different networks that are in Australia. If I want to accept them through this ISP, then within BGP I can create a policy and prefer them through this ISP. And what are the different prefixes or networks that actually I can afford to have a longer latency, I can get from another ISP. But there are different tools as well which actually can analyze this information, and then they can change the routing advertisement based on the latency. They will keep on track of the latency. You can see, you can have some sort of tools where you can monitor the different destinations, and then if you see like you have a better latency through another ISP, then you can change your advertisement. But you have to build. There is not I have not seen any open source tool which actually you can use it. Maybe I'm not aware, but there are some commercial tools. Otherwise, you can have like write some scripts and then use it.
Can you provide some of those tools for us as a reference? Because if we are using two transit provider as multi-homing, what you just said is valid, because we are paying for the ISP to provide a transit service. We can ask them to provide the latency table before we make the commitment.
Yes.
But for peering to an IXP, and then we have a B2B relationship with the customers of the IXP, then there's no way we could know the latency of that ISP that we are peering with.
Okay, so
we are in a sort of eco position. We cannot ask them to provide the latency information behind the network, because they will just provide peering information through the internet exchange.
yes. So
Unlike the transit provider.
okay, thank you for your question. So when we are going for to buy a service, obviously the ISP can provide us. We can ask them what is your latency metrics, and maybe the tier 1 or tier 2 operator, they have this information on their websites as well. If you go to their website, you can see there as well. But when we are going to internet exchange point, your point is valid. Like you are going to peer with multiple other networks, and they have not maybe published their latency. So in that case, it becomes our own responsibility to check the latency, because when you are going to establish the BGP, at that time you can maybe ask them, or you can measure that as well, because there is no other way. Because until unless you do not have any direct connection with them, you cannot measure. It's just like if I want to measure how far this wall is, until unless I go travel there or took some measurement tape and measure it. But by looking at it, I can just assume like how far it is. Similarly, until unless you are going to ask them, okay, I'm going to establish a BGP session with you from like Tokyo, and their network is maybe in Yokohama. So one way is like you can ask, other way is like you can assume what is the physical distance. But sometime the physical distance and the fiber cable distance could be different. So every 100 kilometer actually adds 1 millisecond latency. And then every device which is going to come between the network, it adds also 1 millisecond. So how many devices in the middle you have, they are going to add 1 millisecond, and after every 100 kilometer, you will have 1 millisecond as well. So these are different ways, like there is no automated way, but there are tools. But then first you need to have the connectivity to measure it. Like within Cisco, there is IP SLA they have. So on the router, you can configure an IP SLA, and then you can measure the latency towards the remote side, which you configure, and it will keep on sending the packets. and then you can like use SNMP or maybe use other telemetry to get this information and have this information over the NMS. Similarly, in case of Juniper, there is also way to measure this. I believe the other vendor, they have also different ways to do this. But you can use some of the, like your NMS to get this information and then trigger some action based on this latency. Because mostly we do this when we have L2 L3 VPN. So we do this kind of information. But there is one commercial tool, I can name it, which is Noction actually. It actually provides you to way to, if you have only two ISPs, you can use their free version to manage your connection. But if you have more than two, then maybe you have to pay. So maybe you can search for other tools, but this is the one I know, since you were asking like what is the tool which we can use. So their free version is available if you have just two ISP or two external BGP connection. The other way is like you have to use the net flow. So in case of net flow, you are able to know, okay, which of my connection is giving me what different, like if I have 10G connection, so what is coming through this? Through this 10G, I'm connected with Google, with Facebook, and other 10G I have with another ISP. From there, I am maybe connected with some other networks. So when you see this information, then you can shuffle your traffic based on the analysis. So you need to have some sort of monitoring tools to actually monitor your BGP, monitor your link, and see what is the traffic you are receiving, what you are sending towards them. So only then, because the monitoring is something which the activity which you will keep on going until you are going to have the network. So you have to do over the life of the network.
Excuse me, are you going to cover something on SD-WAN and the best practices?
No, unfortunately, no. I had another session 2 days before on the segment routing. That was related to the SDN, you can say.
SD-WAN?
Not SD-WAN. That was the segment routing. But we can discuss after the class. Okay, let's move on since we are just halfway. So as we were talking about like how we can manage our connections, so that's called the traffic engineering within the BGP, and actually ASPath help us to control our traffic. And when we want to do the traffic engineering, what we are actually doing in case of BGP, the prefixes we accept is actually give us the control how we are going to send the traffic. So you are giving me some information. If I accept that information, so I will be able to send you back something. And what I advertise, based on that, you receive the traffic, I receive the traffic back. What you advertise to me, based on that, I send you back the traffic, and what I advertise, based on that, you return me traffic. So the advertisement and traffic, they are both reverse to each other. So there is one parameter which is actually used in case, that is called the local preference, which actually help us to select the best path in case of outgoing traffic. So it is the first BGP selection criteria. Like I'm receiving prefixes from two different ISPs. Now I want to select the advertisement from one of them as a best. So I attach the local preference, higher local preference with one ISP, and the route advertisement received from this ISP is considered as a best. So the higher local preference, it is considered as a best. So that's why when you are going to define your rule for the local preference, so you need to think about how you are paying and who is paying to you. So remember, if you have any customer, then you need to prefer your customer routes. Because if you will not prefer, then the same customer route may be coming from the ISP is received to you, and you are sending back the traffic to the ISP instead of sending back to the customer. So it's just like this. we are in this room, okay? If I am receiving some information from this side, okay, and I am not preferring that information, and the other side is also giving me the same information. Now I will send back the information from this group, and they will pass it to this group. But they will see, okay, even I am serving, but they are seeing like this group is giving them information. So similarly, it happens in case of BGP. If you do not prefer the route advertisement from your customer, then if it is received from any other network, you will send back the traffic to there. So now even you are like serving that customer, but the traffic is going through another link. It is not going over the direct link because you have not preferred the prefixes from there. So the customer will see, okay, traffic is not coming from you, it's coming from someone else. So you always need to prefer your customer link. Whatever you receive from customer side, it should be higher local preference. Because if then you will be able to send directly traffic to the customer, and customer will see, okay, I am receiving a service from you. Just to let be more clear about this. Okay, if we see this, like this is the internet where we have some website, okay, and here this AS 17821, it's advertising the prefixes to ISPA, and it's advertising to also to ISPB. So now the ISPA, when it's received the prefixes, it put the local preference 200. Okay, but this ISPB, it said it does not actually put any local preference. So it keep is like maybe 100. So it will advertise towards the internet, and same advertisement will come here. Maybe it, when it receive from internet, it put 200 here as well. So now whatever the information is coming over the internet, this ISP has selected as a bus. Now the traffic, return traffic, it will not be sent back over this link whenever some traffic is from here. It will always be going from ISP B towards internet and towards ISP A and then back. Because the higher local preference is coming through the internet. So that's why whenever the both ISP, they are going to receive the any routing information from customer over this link, they will set something 200 or beyond plus 100, because 100 is by default there. So whenever you receive the routing information, the local preference is 100. So you need to set higher local preference for the routes received from your customer. So when the traffic goes back from your network, it always goes back on the direct link instead of going back from the internet towards this side. So in this case, whenever there will be any traffic, if they set higher local preference here, so the traffic will come back from internet, it will go back like this. So that's why when you establish a BGP with your neighbor as a customer, you always set higher local preference than you have set whatever you are receiving from the internet. So the customer information is always preferred and selected as a best. Then you can set after customer, like for customer, I can set local preference 200, and for peers, which I'm connecting over the ISP, I can set maybe 150. Sorry for my writing. And for transit, maybe you can set 100, keep it 100 or keep it like 120. So that's mean whenever I'm receiving any route from the ISP or from the transit provider, that is less preferred, the peer is more preferred, and customer is higher preferred. So whatever I am receiving the routing information from customer, it will be always have higher local preference, it always be selected as a best path, because I want to send back the traffic towards the customer. If I am not setting the customer routes as a best, I will not be able to send back them the traffic. So another thing in case of traffic engineering is how we can manage is through the AS path prepend. So in case of BGP, the by default the criteria is to select the shorter AS path, because you have the AS path information along with the prefix. So the copy of the route which have the shortest path AS information, that's selected as a best. Remember we have earlier, let me go back to the slides where we have the AS path information. So we have this AS path information here. So you can see here the AS path is only 2 AS numbers. Remember, if there is if this AS65001 it's advertising these prefixes on this link, then the AS path information it will be just like this. So this network 64512 it will not prefer this copy, it will prefer the copy which is receiving its on the direct link, because here the AS path is only going to be one AS number, not the 2 AS numbers. So when you want to make a route less preferred, you actually try to prepend your AS path. So when you advertise your advertise your prefixes, you append mean you actually say, okay, instead of considering my AS number one time, you can have it multiple times, like more than one time. And in that case, actually, they can see it a longer AS path, and that's less preferred. But if they apply the local preference, then it is actually even the longer AS path, it will be selected as a best. So another thing is like you can aggregate your prefixes, but actually you do that only for your prefixes. Do not do it for the customer prefixes. You can also tag your prefixes with no export community. In that case, the other ISP or the other network is just going to receive this this routing information, and they are not going to share it with somebody else. The another criteria or another way to control the routing information is the MED, that's called the MED, and it's actually used for multiple links with the same network. Like you have two links with another network, another ISP, and you want to select one of the links as a best, then you can use the MED value. Lower MED value on the preferred link and higher MED value on the less preferred link. So I have two links with another network. So I want to use the link A as a best to receive more traffic, and link B I want to use it as a backup. So I will use the lower MED value on link A and less or higher MED value on link B to have less traffic over it. But it's better to like discuss your plan with the other network, because if they change our policy from their side, maybe what you are thinking to apply, that will not have the effect, because from their side they can have a different policy, and what you are having the policy from your side thinking about the MED, so it will not give you the same result if they actually use the local preference on their side. Because MED you can use from your side, and they can use the local preference. Similarly, when you receive routes from other, you use the local preference to select the best copy, which route you want to set as a best. So in case of like we have two direction, inbound traffic and outbound traffic. So in case of inbound traffic, that means what traffic I want to receive from others, I use AS path and MED value to influence that traffic or to control that traffic. And what traffic I want to leave from my network, the outbound traffic, I use the local preference value for that. So that's mean when I'm receiving the advertisement from other, I use the local preference to select the best path or the path I want to select as a best. And when from others, when I want to receive the traffic on a certain link, I use AS path and MED value along with the routes. So that actually influence the best path selection in the other networks. So another way is community is also used for the inbound and outbound, but in that case actually you need to have an understanding and agreement with the other network, because you can attach the community. Community is just like a number. You can attach with your routes. Now the other network need to implement something based on that community. It's just like that. I'm giving you a number 10 and 20, and when you get down to the entrance, based on your number, there could be a bus who can take you somewhere else. But now the guy who is standing at the gate, he need to understand like the number 10, what is the meaning, and number 20, what is the meaning. Otherwise, it is meaningless. I am attaching, but there is no action from the other side. So actually, we use community to have the action on the other side. So when they receive the community, they can recognize the community and then take the appropriate action based on the community. The community is just kind of a tag or a number which actually help you to identify the routes. Even I can attach the community with the my customer prefixes. Whenever I'm receiving the routes from the customer, I can have a community or a tag value for the customer routes. So later on, when I'm re-advertising those routes toward another ISP or over the internet exchange point, so I can use that community to filter the routes or to maybe match the community and to advertise the routes. Because this is again giving me some information. Based on this information, I can take some actions. So let's look into more detail about the inbound traffic engineering. So here we have like an AS 17821, and we have another two AS 20 and 30, which is having connectivity with this AS 17821, and then we have the connectivity towards the internet. So in this case, both of the this AS 20 and 30, they can be used for the incoming and outgoing traffic through the router R1, and for the AS 30, R2 is the path we only use if the link through AS 20 fails. So in that case, how we can configure our network to actually achieve this thing? So we are using this path as our primary path, and this path is our backup path only. So when we want to advertise our routes from here for the inbound traffic coming, I want to receive some traffic over from the internet. So first I need to advertise my prefixes. So when I will advertise over this link, I will advertise without the prepending of the AS path. But since from this network, I only want to receive the traffic when the primary has failed, so I will prepend my AS number when I'm advertising the routes from the R2 towards AS 30. So what about the outbound traffic going from my network towards the internet? So I want to use this link as a primary and this link as a secondary. Okay, for the outbound, I want to use this as a primary and this link as a secondary. So in that case, when I am receiving the routing information from this direction, from AS20, I will set higher local preference here, like 200. And but when I am receiving the route advertisement from the AS30, I will set lower local preference, like maybe 100, or we can say 150. So now I have selected the best copies from this side, so traffic will flow from this side, from AS20, and when it fails, then it automatically switches back to AS30. This switching can take maybe, depending on the routes, 3 minutes or 5 minutes.
Is there an IBGP between R1 and R2?
Between? Yes, they have IBGP session. Because remember, within AS, we should have IBGP. Otherwise, because we have a network here, or let me remember, we have just drawn two routers, but there could be another routers here, another router, and then we have maybe customers. So now, why we need IBGP? Like we need to have IBGP connection between them, because this router, it need to receive the routing information from R1 and R2. This could be your R3 maybe, and you have a customer connected behind it. So if R3 is having IBGP session, that's why it is able to receive the information from R1 and R2 as well. In case this link goes down, R2 is able to send the routing information to R3, and then it is able to send back the traffic towards R2. Otherwise, they will not be able to send back. So in terms of configuration, what is the configuration we need to do in case we want to have active and backup setup? So first we need to have the like BGP session between AS20 and 30. So here you can see the configuration is showing the BGP session with AS20. So I have my neighbor, this is the neighbor IP address, remote AS number, and what are the prefixes I want to advertise towards this BGP peer 20.20.20.1. I have created a prefix list here. So within the prefix list, I have mentioned this /21. So I want to advertise this /21 in outward direction. That's mean from my side, from AS17821, I will advertise this /21 towards AS20. And in the what I want to receive from the AS20, I want to receive the default route. That's why I have put here only the default route. And this is the way to how you actually originate a prefix in case of BGP if you have not received from another protocol. For R2, what we need to do is, so in case of R2, remember we said we need to prepend our AS. So similarly, we will have the our neighbor IP. Let me use another color. We have the neighbor IP here. Then we have the remote AS number. This is telling me what is my neighbor IP and remote AS number. And after that, I have the policy here, like the prefix list. So in case of prefixes, same prefix I want to advertise, but I have also attached a route map here, because in previous configuration, maybe you have noticed we do not have any route map here. We have only the prefix list. But in order to prepend the AS to make it like worse other than the AS20, I want to have the prepend. So what in that case I am saying, when I am advertising these prefixes, we have a route map, and within the route map, I am saying prepend my AS 3 times. Okay, 17821, 17821, 17821. So as a result, when AS30 will receive the route, the 17821 it will be 4 times. 1 is by default and 3 I am adding. But when AS20 is going to receive, there will be only 17821 only once. And remember, the shortest AS path is going to win. So as a result, when R2 will advertise to AS30, it will go towards the internet. The copy from AS30, it will have 17821 4 times. But from the R1, when the advertisement will go towards the internet, it has 17821 only once. So since the copy from which is going from AS20, it has only the AS number 1 time, so it will be selected as a best. So this is how you influence the route selection in a remote network. Because I want to influence the route selection in a remote network about my prefixes, so I use the AS path prepend in that case to control this. So what about the routes I am receiving from the AS30? How to make them less preferred and more preferred from here? So here you can see in the inbound direction, I also have a route map, and if I check the route map in the inbound direction, I set the local preference to 80. So that's mean the local preference 80 is here, and from AS20 it is 100. So 100 is more preferred. That's mean whatever the routing information I am receiving from my neighbor AS20, it's more preferred, and from the neighbor AS30, it's less preferred. So this helped me to, when I'm sending back the traffic, I will be able to send back through AS20.
Excuse me, if the remote network using local preference, they override your AS.
Local preference, no, if you are saying when I'm prepending and he is using local preference, yeah, that can override as well.
So AS prepend cannot guarantee.
It cannot guarantee, but you can try. The other way is like you can advertise if you have a like /21 and you want to be make sure, dead sure, like whatever he does not counter your policy. You can then advertise a supernet from one side and a more specific route from another side. Like you can advertise a /24 from AS20, and you can advertise a /21 as well, but from AS30 only advertise /21. So in that case, you have not advertised the /24 from AS30, so he cannot do anything. So in that case, so out of this 21, remember you have 2 raised to power 24, 2 raised to power 3. So that means you will have 8 prefixes out of this. So one of the /24 you can advertise from here. So in that case, that would be always preferred from this side. Whatever he does from his side, until unless his link is alive, he will not be able to do anything.
Is there any common practice we can apply? How many AS prepare we can apply?
Normally it's set to prepend only up to 15 times, because sometimes few of the networks, they actually apply some regular expression and check the AS path length. If it is greater than 16, they just drop that copy. Because nowadays, if you want to travel from one network to another network, the AS path length, average AS path length over the internet is something 4.5 or around 4. Because if you want to go from Japan to any other network around the world, in between you and your destination network, there will be only 4 AS path in total. In future, it's going to be maybe reduced to 3, or because earlier it used to be more, but over the time we have more direct connectivity between the networks, so AS path length is decreasing over the time. That's why it's considered that 16 or maybe 20 is a good number to use in your regular expression. If you see something greater than that, then maybe it's not useful. Or you can maybe set a less local preference for those AS path having such a long length. So you will still have the copy, but if there is a better AS, that is always preferred.
Excuse me, the way you configure this, if I'm not mistaken, the local preferences is higher in terms of the selection criteria.
Yes.
Compared to the AS path.
Yes.
So what will happen if 17821 want to go to AS30?
Okay, so in that case, actually you apply a regular expression, whatever I have in the upcoming slide, this scenario. So actually his question is, in this case, if we apply a lower local preference for the advertisement we are receiving from AS30, so in that case, everything would be preferred from AS20. So when we want to reach only from here to here, so even we will be going over this path. So in order to cater that, actually when we receive the advertisement from here, we apply the a regular expression or a prefix list to filter the routes which belongs to AS30 and set a higher local preference for them. And whatever is coming from the internet through AS30, we keep the lower local preference for that. Thank you for asking the question. Okay, let's move on because there are still 30 slides left. So in case we need to do the load sharing, so then how we can do is we can announce the sub aggregate prefix on the first one, and on the we can also do the same on the another link, and we always announce the supernet from the both of the sides. So when we are receiving from them, so we want to split the traffic. So then customer need to assign some address blocks, which actually they advertise from here. So the first one is like you advertise the same /21 from both sides. So when you will receive back the traffic, so now it's up to the networks here how they select the best. So in that case, you will receive some traffic from here, some traffic from here. But if you based on your NMS, you see utilization okay, you are receiving more traffic from AS30, then you can maybe split your prefixes again or reshuffle. So how we do that in case if we want to have the load sharing? So this is again the same configuration. We have the BGP with AS20, and in that case you can see we have divided the 21 into a 222. So within 21 we have a 22, 248/22. This we will advertise toward AS20, and the second one, when we will go to similarly when we will go to the AS30, so you can see here we have the second/22. So within a 21 you have 222, and similarly maybe you can do a mind math as well, like 22 minus 21 you get 1. 2 raised to power 1 is just 1. That means 222 you have within a 21, and this actually helps you to keep that 22 on the AS30 and other 22 on AS20 as well. But if you have more traffic on a certain prefix and still you have divided this into half, still your traffic will not be equally load balanced. So it will always not be 50-50, it could be like 55-45, or it would be 60-40. So you cannot guarantee always 50-50, you can just try that, but this will not be the case always. So for outbound traffic, remember the full routing table, it requires consume the memory and CPU hungry as well. So that means you need to consider your router memory resources, memory and CPU utilization when you are considering to accept the full routing table, because in that case you are going to accept the around 1 million routes nowadays. So now you want to have the higher local preference for the routes originated from the AS30, like the question earlier raised. So if we want to have higher local preference only for this network, but whatever is coming from the internet, we have like maybe we can set 100, and whatever is originating from AS30, we can set 200. So in that case, only the network which is connected here, like maybe a server there or PC there, it will always be using this direct link. But whatever the traffic coming through internet, it will prefer the other path in that case. So let's see how same thing can work if we accept the AS30 from this direct link or the network which are connected with AS30. We can set the higher local preference for them. So that means whatever the traffic needs to go back towards these network, they will always be using AS30. So not only AS30, even you can select the AS30 and other networks connected with AS30 and have a separate policy for only these networks here when you are receiving the routes. For the rest of the internet, you can prefer AS20. So this actually you need to do when you are peering on the internet exchange point, or you're building the peering with other networks. So you need to come up with your homework. Okay, what are the different networks I want to reach towards this through this ISP? Previously, I was working in Qatar, and I was getting this requirement from our customer, like I want to reach to Saudi Arabia for this and this network. So then I have to select, make a regular expression, and attach that regular expression with our peering towards this country, and only select those networks. Because if I just do not select the networks, everything coming from that ISP, even I'm going towards Europe, it's selected best from this route. So you have to be selected what you want to do, and only for those networks actually you can do. Sometimes you can ask other networks to provide you a community for their network. So when they advertise you routes, they attach a community. So you actually then match this community and apply the higher local preference. And in that case, it's become easy. But if they are not helping you out they said, okay, we cannot do this, or this is not our policy, then you have to do everything from your side. You have to make a regular expression, match different networks within that, and then apply the policy according to your requirement. So let's see what is the tentative configuration in that case. For the outbound traffic, we have for the AS20, we can set, we have a BGP and then prefix list, everything. So earlier we said only this is default route, but with LE24, actually we are saying not default route, complete internet routing table up to /24. So we only, in case of internet, remember there is another rule of thumb. When you advertise IPv4 prefixes, you only advertise a prefix maximum having the prefix length /24. You do not advertise 25, 26, 27, 28, up to 32. You only advertise up to 24. And remember, when you need to accept from others, you only accept up to 24. Anything bigger than 20, the prefix length greater than 24 is like 25, 26, you need to drop. So this actually syntax is like any route, and it should not have, its prefix length should be up to 24. And you also need to filter the bogans. So remember, there are prefixes which we do not need to exchange with each other, and those are routes considered to be not to be seen over the internet, and you should not advertise. Those are the private prefixes, or the prefixes used for multicasting, or the prefixes for documentation, or used for testing. When we establish the BGP session, we first need to filter those, so someone else cannot send us the wrong information, or cannot send us the garbage which do not need to be received from other. And when we are advertising to other, we also need to filter the bogans. So as a result, I will be able to receive the everything from the AS20. And what I need to do for the AS30 in that case, so I need to establish the BGP session, then I need to attach the prefix list. So what is in the prefix list I have? So you can see in the prefix list, I'm denying the bogans, then I'm accepting everything to accept the full routing table. But then I have another route map here. So in the route map, I am saying any that when I receive these prefixes, also check the AS path. Okay, within AS path, I am saying that if the AS path had started from AS30 and there is no other AS, like $, it's saying me space, and then it should end the AS path. But after that, I am saying another AS path could be like my neighbor, it should be AS30, and after AS30, there could be only one other AS. So that means AS30 and its peer, AS30 and its peer. So this 0/9 mean there could be any combination using 0 to 9 digits. So it could be 30, then it could be like maybe 20, 35, 125, 100, 200, 900. So using these 0 to 9 number, it can be any combination. But there should be, the length should be only 2 AS. And if this is the case, okay, then it says, oh, we go into the this route map, it sets the local preference 150. And other than that, it is setting the local preference 20. So for the outbound traffic, what we need to do in that case, we go to the configuration of AS30. We can see the prefix list we have. Sorry, this is the same full route. In case of partial routing table, if we do not want to receive the full routing table, in that case, what we need to do is, so we can have maybe local preference 150 based on this criteria, this AS path, and for the others, we can set the local preference 50. So for these one, it will be 150, and for the rest, whatever we are coming, it will be only the local preference 50. So in that case, these networks will be preferred. For the internet, we will be preferring AS20. So in order to load share the outbound traffic, we can have a partial route as well in case we do not have enough resources on our router. So we can select some of the routes, and those could be like based on our requirement, and we can only accept those routes, and we can accept the default from AS30. So in that case, we are saying, okay, accept the default route from here, but we can accept the specific routes from here. So in that case, it can give us the better connectivity towards these connected AS, but whatever we need to do, go towards internet, we can just use the default route. So we can filter to accept only the prefixes originating from AS30 and its neighbor, and we can set the higher local preference, and for the rest of the internet, we can use the lower local preference, which actually help us to just use the default route. So the traffic to the internet or the rest of the world, it will actually go using the AS20 instead of the AS30, but just traffic towards the directly connected, it will go over the direct link. So this is actually the scenario which we earlier received the question as well. Again, the load sharing for the outbound traffic. So let's see how we can do that. So we can accept the default route in that case, and but for the AS30, again we can use the we can set the local preference, and based on that we can differentiate what we need to receive. But in this case, we are not receiving the full routing table, we are just receiving the default route because we have not mentioned here LE24. So this is the scenario where we are just receiving the partial routes, we are not receiving the full route. So we are only accepting the routes which are belonging to these criteria, and then for the internet, we are just using the default route. Okay, let's see, there is another way or another attribute we have, which is the BGP community. So actually BGP community is an attribute which provides us the flexibility to do the traffic engineering other than the prefix list, and it also helps us to simplify the BGP configuration as well. So by default, it's not sent to other BGP neighbors. So you need to explicitly specify this when you have the neighbor statement, neighbor, IP address, then send community. So this keyword you have to mention in your BGP configuration to enable the exchange of community. It's just like we are in this class, and if we want to address each other or share some tag like group 1, group 2, so we need to first decide, okay, this is we are going to use the mechanism. So similar, this is just a way to telling your capability to your neighbor. So this can be used to send some policy information to your neighbor, like you want to set local preference 80 in another network when it receives the prefixes from you. So you use a tag value of 80. Like I'm saying, okay, when I'm giving you a parcel, okay, and if it has color blue, use the set the local preference 100. If it has color red, set the local preference 200. If it has color white, set the local preference 1000. So based on the value, you want the other side to take some action. So that's why we actually use it. Similarly, if you want to ask the other network when they receive your prefixes and they re-advertise to other, so they prepend them or do not prepend them. So based on some value, you can actually have this agreement with them. You can also use the community to do the black holing, because in some cases we have the like we receive the attacks on our prefixes, and we want to ask the other networks, okay, do not send me traffic for this prefix or this IP address. So you attach the black hole community, and they actually then drop your traffic. Instead of sending towards you, they send towards the null network or toward the scrubbing server, and then you receive the filter traffic. You can also change the next hop. In case of bogans, actually this help, and you can use a community as well. So community actually is a way, flexible way to have some action in other networks. Or within your network, when you receive the routes from the customer, you attach the community, and when you want to advertise towards your neighbor, you just match the community and advertise. What based on a certain community. Maybe some of the customer, I want to advertise towards the internet exchange point, and some customer I do not want to advertise towards the internet exchange point. How I will decide? Because on the other router does not know about the customer. It's the human who knows. So as a human being, we need to attach some community to filter my prefixes. So when they go to another router, so the router will know, okay, this router, when it receives the prefixes, it has attached the community. When it goes to another router, that router actually use that community to again decide what needs to be advertised, what needs to be dropped. Let's see quickly how. So there are two types of format in case of community. One is 2-byte ASN, one is 4-byte ASN. So actually in case of 2-byte, there is only 16-bit integer you can use to represent. But in case of 4-byte ASN, we have the private like ASN and then the number. So in that case, we have 96-bit integer. So it actually help us to fit in any number, because in case of 16-bit, some AS number cannot fit in. Because only 2-byte AS number can fit in, and then you can have a number. Let's see how it look like. Before we go to the configuration example, so there are some well-known communities that are actually used between networks. So like no export, do not advertise or export to any BGP neighbor when you receive any route with no export, and only extend to the neighboring AS. And if you receive any route with no advertise, that means do not advertise to any BGP neighbor, just keep up to that router only. No peer mean do not advertise to any bilateral peering, and black hole is just to send the traffic towards the null. So filtering routes using the BGP community. So it's actually a way you can import a route from a customer and create a static route. Like you can use the community to control export to the other peers and transit. Like, okay, I have two connection going towards another network. Now my customer, I want to give the flexibility to customer. Okay, from my network, I have these two connections. If you will send me your routes with this community, they will go over the link 1 from my side when I'm advertising to others. And if you will give the route without community, I can maybe send towards the both. So now you want to give your customer the flexibility to have the control how you are going to advertise their prefixes. So you ask the customer, okay, give me routes with this tag, so I can have a different kind of treatment for your prefixes. So this you can decide with your customer. Maybe or sometime customer actually asks this, okay, give me this flexibility, because you have number of links from your network going towards other network, and I want to prefer a certain link. So we also use the community, like I said, to filter the links. So this link could be the upstream or the transit provider. And like some of the transit provider, actually, they provide this community to their customer. So when they receive the routes, if you attach this community, so then they can have a different kind of treatment or advertisement for your route. So like in this case, I have example of entity. So how they actually, you can go to this link as well to check their policy though. So instead their customer comes back to them and asks them for different community they actually have published on their website. So if their customer want to advertise their routes towards the US, they can advertise the routes with this community. and if they want to have like towards Europe, Asia, and South America, so they can use these communities. So in that case, the routes in US, they will be received to one of the ISP with this community, and if you do not attach, then they are not going to advertise there maybe. So you can plan the BGP community tagging, like you can have maybe your NRAN and then number which you want, your AS number, and then a specific number you can decide. Like for the default route, you can use your AS number and 100, and then to route receive from the transit, you can have like 10, and then the transit number 1, 2. Similarly, you can do it based on the like regional NRAN 20, and then their number as well. But since 2 byte, in case of 2 byte, you only have 16 bit. So if we use the extended community, that actually help us to fit in everything. But actually, as I said earlier, community we use to have some action based on that. You attach the community, and then you want to take some action. So you have to actually decide this within your network or within your peer, what you want to achieve using the community. So you can have an agreement with them, okay, when I will advertise routes with this community, I want this action from your side. Or maybe they can send you community, okay, if you attach this community, based on this, I will take some action. So we actually publish our BGP community as per our plan on our websites, depending on our requirement. And then we ask our member to tag their announcement with the corresponding communities. So you can have to apply this community on your border router when you are doing your configuration. So this is an example how maybe an NRAN can have their community to select the routes from other NRAN. Like they can decide to have maybe a community, their AS number, and community 36 for the NRAN in Australia. For the NKN, they can maybe have 356. So this number you can decide, and this could be your AS number as well. So previously we discussed the standard community. The other is the BGP large community, where you have the operator's AS number. You can define a value, and then you can have another value as well. So this is a long number which actually help you to have more combination, and your ASN can fit in within this as well. Again, this is an example for large community. You can have your ASN, a number, and then another number. So now we have like 3 different parts. So based on this, it helps you to give more combinations. So this is again the example, like you can have your ASN, a number, and then the transit ASN. So based on that, you can decide a plan, and then maybe advertise it, discuss it with your peers and customer to have action as well. This is again the example. So that's the end of the section. If you have any questions, please feel free to ask me. Due to the time, sorry, we have to at the end a little bit rush, and we cannot have a lab. Otherwise, if you want to do a lab using APNIC Academy about the BGP, about the traffic engineering, we have some lab available. And if you want, I can show you here as well the links. Otherwise, you can go to the academy.apnic.net, and there you just need to log in using your email address, and you will be able to do a free lab as well. It will take maybe 1 hour or 2 hours. I'm not saying do it now, do it when you have time at your home or maybe over the weekend. So last thing I would request, if you can scan this or go to this URL to provide a feedback about this session, that would be very nice. So when you will open this URL, you will see the link, and from there you have to select the training session. So remember, the red arrow is showing the training session. So please select that and provide your feedback. This will help us to like maybe improve or change the something about this session as well in future. If you have any question, I'm available. Please feel free to ask me.